Hello everyone, this is Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I am going to take the video lecture series on chemistry. The subject code for chemistry is 3110001. In previous sessions of this particular subject, we have started our chapter number 8, which is analytical techniques. So in analytical techniques, whatever we have observed till now is basically that how many types of analysis are actually there. What do you mean by analysis? Along with it, we have also seen that which are the types of analytical techniques actually present, right? So it involves different techniques. Say for an example, electroanalytical technique. So electroanalytical technique actually involves the field, the electric field and the analytical field, or the application of electric field in your analysis. That is how the electroanalytical methods or electrochemical methods actually came into existence. Similar way, we have already seen that what you understand by various kinds of chromatographic method, or what is a chromatography. We don't have seen it in detail, that we will have in our next particular subject, but this is basically about spectroscopy. What is the meaning of spectroscopy? How spectroscopy can actually be used for further analysis purposes. As well as it also gives us an idea about the quality, that means about identification as well as about quantification of that particular subject or of that particular sample. Okay, so the meaning is that here that we are going to start with typical spectroscopic methods here, right? So till now whatever we have observed, that is, we have seen about potentiometric titration, we have seen the conductometric titration, and we have observed what is actually the pH meter is or pH metry is. So these are the things that will be used in primary basis, or I should say in preliminary examination. So when we get any kind of sample for analysis, what we will have that we have to do the preliminary examination of that particular sample. After doing preliminary examination, like its state, its color, how it behaves with other chemicals, etc. After doing that kind of examination, we have to do certain kind of instrumental analysis. So in instrumental analysis, we will move ahead with basic ones. Which basic ones which can be include? So that includes pH meter, that can include a conductivity meter. Along with it, it also includes the potentiometer. These instruments are used for endpoint determination, for titration purposes, or for identification purposes of a given sample also, right? But when we talk about spectroscopy, at that time we have to understand that there are particular techniques which can be used for exact examination or exact analysis of our sample. So these techniques are referred as BIST techniques, and they are widely used in each and every field. Say for an example, it can be a food industry, it can be a chemical industry, it can be a pharmaceutical industry, and even it can be a normal petrochemical or any kind of normal restaurant or R&D lab, right? There you can use in petrochemical, fertilizer industry, etc. Nowadays it is most widely used in biopharmaceutical industries, right? So you need to understand that when and how we are actually utilizing it, right? UV and IR, these are the two techniques that we are going to study in our spectroscopic part here. They both are hyphenated techniques, they both are almost used everywhere, okay? So they are of much more importance for all of us. Let's begin with it. To understand what is the principle of spectroscopy, we have to first understand that what is actually spectroscopy. So, spectroscopy is made up of two different words. Number one, spectro. Number two, scopy. So, when we divide spectroscopy in two parts, we get these two things, right? So, spectro means electromagnetic spectrum. Scoping means to measure. To measure whatever kind of or whichever kind of different phenomena observed through the light that we will study in spectroscopy, right? Here you need to make sure that the radiations, the spectrum contains the radiations are known as electromagnetic radiations. So they can be or they will be ranged from the whole range, the Vibgyor range will be covered here, right? So depending upon the type of region, depending upon the frequency in that particular region, we will move ahead in our spectroscopic method. So here spectroscopic methods which are based either on absorption or emission of radiation can be a UV based upon ultraviolet region is being used. So it is known as UV spectroscopy. When we use visible region, then it will be known as visible spectroscopy. Now, when we use UV and visible both together, it is known as UV vis. Okay, so UV vis basically ultraviolet visible spectroscopy. Okay, so in this manner, this will move ahead. Okay, similar way we have infrared. So infrared is for IR because we will use here IR region. So it is known as infrared spectroscopy. Similar way, if we use microwave region in our spectroscopic method, then it is referred as microscope, or basically we can refer as microwave spectroscopy. Okay, this is the way that how it can actually be defined or how it can be nominated. Then we have radio region. This radio frequency region will be used by a very important technique which is known as NMR. NMR stands for nuclear magnetic resonance spectroscopy. These frequency ranges are actually most commonly encountered in traditional food analysis laboratories as well as chemical analysis laboratories. Now, let's move on to the principles of spectroscopy. So when we talk about the principle of spectroscopy, we need to understand the phenomena which are involved in it. Here, the phenomena which are involved are determined depending upon their absorption, depending upon their interaction. So what will happen here? As you can see in the image, we have a sample, we have a matter contained in a sample tube. On that, we will impart or we will incident a light beam. Light beams of a specific region, make sure of a specific electromagnetic region, right? So when it gets imparted on it, now that light and the substance or the matter, the molecules of matter or the atom which is present in the matter will react with each other. Okay, the interaction will occur between them. So what will happen? Either absorption will be there, either photoluminescence will be there, transmission will be there, or scattering will be observed. Even reflection can also be observed in such cases, right? So depending upon phenomenon, we will classify our spectroscopic methods. For an example, absorption, that means whatever or whichever amount of light we have incidented on the matter and which amount of light will be emitted or whatever we got after the analysis done. So whatever we have given and whatever we came, the difference gives us that this much amount of radiation is being absorbed by our matter. right? Why it uses such kind of thing? Because here comes the actual principle that the atoms generally remains on the base or generally remains at ground state level, right? So when they get exposed to energy, either in the form of heat, either in the form of light or any other form, it will absorb that particular energy and will move from ground state to excited level. Okay, so at that time it requires an energy to move from the ground level to the excited level, and it will absorb the energy from there. In this manner, it will move to the excited level. Here we get an absorption. Okay, so the phenomenon is absorption. Now, next one will be the actual one, that is the emission one. What will happen? In general cases, certain kind of atoms have the tendency that they will or have the energy to move from ground level to excited level. They have the energy, so they can move from the ground level to the excited one. They move there. Now the extra energy is also imparted on it. So now what will happen? When they came back from that excited state to the ground state, they emit the light. Okay? This phenomenon is referred as emission of light. Similar way, we have another, that is transmission. The light can be transmitted also, right? And photoluminescence. What do you mean by photoluminescence? So here you will get the light or the emission in the form of light that you will observe, because certain kind of elements show such kind of behavior. Okay, so at that time they shows you photoluminescence. Similar way, scattering can be observed. The light that is incidented on it will be scattered by the molecule. Here the shape of the molecule plays a very important role. So it will get again scattered by it, and the light will be scattered in different directions. Right? Raman spectroscopy is based upon this principle and is known as scattering spectroscopy. And Sir C.V. Raman get Nobel Prize for this or for finding out this particular phenomenon. We can have a reflection also. Certain kind of molecules get reflected or can show the sign of reflections, right? So these are the things, these are the phenomena which can be observed when we deal with the principles. These are the principles of spectroscopy, that how the behavior will be there. Okay? So spectrometer is an instrument designed to measure the spectrum of a compound. Here two kinds of spectrometers can be there. Number one, absorption. Number two, emission. We will use it here. Okay. Generally, the technique is known as spectroscopy. The method is known as spectroscopic method. The instrument is known as spectrophotometer or spectrometer. Right? The frequency, whatever is absorbed, whatever is emitted, whatever is reflected, or whatever is given by the particular material or scattered by that particular matter, is individual characteristic of that particular atom, and because of it, it is or it will give us the identification of that particular compound. Right? This is the base of our spectroscopy. This is all for this session. Next we will see in our next session. Thank you so much everyone.